हेलो।
आ गए।
हाँ, यस।
ओके ठीक है, हो गया सब।
हाँ।
ओके, सो टुडे टॉपिक इज, हेडिंग डालो, क्या लिखा है?
पावर इन एसी सर्किट।
Okay, so today we will discuss about the power in AC circuit in different cases when it contains pure resistor, inductor, capacitor, LR, CR, etc. Right?
हम्म।
Hmm. So power in AC circuit we'll discuss about. Acha, one thing before starting this topic, I would like to mention here that as we have discussed the phase angle which is given by phi is equals to tan inverse of xc minus xl upon
Well, upon
xl upon r, right? So we have
हम्म।
discussed this thing. And another thing, that the net impedance of the series LCR circuit is given by square root
रूट
of r square plus xc
प्लस
minus xl of whole square. Okay, now for the LR circuit, suppose I have LR circuit. So for the LR circuit, it means it will contain only the inductor and resistance, it will not contain capacitor. So in that case, xc will be equal to 0 only. So only this condition you have to make use in these two, so you will get the formula for the LR circuit. For example, for LR circuit, phi will be tan inverse of xc is 0, so simply this is xl over r, right? Moreover, this is the mod value. And the next is CR circuit. When the circuit contains capacitor, and resistance only, so in that case XL will is equal to 0, that is inductive reactance will be equal to 0.
जीरो।
And for that phi will equal to phi is equal to tan inverse of xc upon r, and the impedance is equals to r square plus xl square, right? So this is very common thing for the LR and CR circuits. Only these two conditions we have to use for the LR and CR circuit. So our topic is that the power in AC circuit, right? So when we have the DC circuit, in case of DC, what is the formula of power? We know that work upon time means electrical work upon time, right? So power is equal
हाँ।
to, we know that work upon time, which is electrical work upon time, and V potential is defined as the amount of work done to bring a unit charge. We have studied in electrostats. So from here we get W is equal to V into Q, right? So when we use this condition here, V into Q upon T, and we know that Q is equal to I into T. So when you put and solve, so you will find that power is equals to V into IT. Fine. But this is in the case of the DC circuit. In the case of DC circuit, you have the formula I square R. One second, there is no T. I square R, V square T upon R, etc. We have discussed in the previous classes. But when we have the AC circuit, so it is a matter of not only the voltage and current, but also the matter of their phase angle between, right? Because phase angle also plays an role in the power. So therefore we need to individually specify the powers in AC circuit for CR circuit, LR circuit, LCR circuit, and the pure resistance only. So one by one we will see on that. Okay, so first case is, हेडिंग डालिए और लिखिए जो लिख रहे हैं, राइट? when when circuit
When circuit
circuit contains, and you have to note it down as well, contains only pure resistors. Pure resistor means purely resistive circuit, right? Uh, so when circuit contains on, okay, we are not going to draw the circuit diagram again. We have done that many times. Now we are familiar with that. Since it contains resistance only, so we know that the applied voltage equation is V is equals to V naught sine omega t.
and omega
This
t.
is okay. And the current equation is similarly I is equals to I naught of sine omega t, where t is the instantaneous time, and what is the omega? Omega is the angular frequency, you can say.
See.
Okay, and angular frequency is equals to what? 2 pi f. Or in other word, you can also write this like 2 by t, where t is the time period. Fine. Okay, we have to find out the power in AC circuit. Okay. Hello. So in order to find the power, it means we will take the average power of the circuit. So first of all we will calculate the power, then average power. So why there is a concept of average in case of AC, not in case of DC? Because of, in the case of DC circuit there is no fluctuation between
mm,
voltage and time, right?
mm,
So there is no concept of voltage because the voltage remains constant at any at all the instant. But in case of AC there is fluctuation like this. Okay,
mm,
so it means at a one in time period t, its value becomes positive, negative, 0, positive, negative, 0 many times. Its value is increasing and sometimes decreasing continuously. Its values increases and decreases following the sinusoidal graph. So when we have to find out the power, so there is concept of the average power. Why average power? Because at some points voltage is increasing, some point voltage decreasing, and so on. So this is why we will take the average power for one period. समझ में आई बात?
mm,
डीसी के केस में कोई एवरेज का कॉन्सेप्ट नहीं होता है, बट एसी के केस में होता है.
mm,
ओके, सो फर्स्ट वी विल फाइंड आउट द पावर. So power P is equals to, we know, V into I. V into I means in place of V we will put sin naught sin omega t. Achha, one thing that here we have used the V naught and I naught for the maximum voltage and maximum current, but in
हाँ,
your book I think there is Vm like
right,
this and Im. Okay,
mm,
so that doesn't create any difference. So these two are same. You can use anything which you want. So V naught into I naught, and in place of I we will substitute what, sin naught of omega t. Fine.
हाँ,
Okay, so this means that power will be equal to V naught into I naught, and sin omega to sin omega t, this will become sin square omega t,
mm.
right? Okay, so now what we will do,
अ,
any doubt?
ये साइन स्क्वायर ओमेगा टी स्क्वायर क्यों नहीं बन सकता?
क्या हुआ?
ये साइन स्क्वायर बन गया और ओमेगा टी स्क्वायर भी बनेगा क्या?
No, 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 omega t square nahi banega. There is the product of the trigonometric term, not in the angle. Like when we write sin x into sin, see one thing here. Okay, see one thing. Suppose I have written here sin x into sin x. Okay, so
हम्म,
this is the product of the two trigonometrical term. So this will take the form like sin x the whole of a square, or you can write like this. But when we write sin x into x, it means we are multiplying those angles. Then we will get sin x square, about which you are talking about. But there is a multiplication of the whole trigonometrical term. So this is sin square omega t, not sin omega square t. Fine.
हम्म,
Okay. Any doubt?
नहीं.
Okay. So we have found out the power in the case of when circuit contains. Achha, what is the main point when circuit contains a pure resistor? We have discussed up to so far that in case of pure resistor, voltage and current are always in same phase.
हम्म,
Have you remember or not?
yes.
It means there is no difference in phase. That's why we have taken the term sin square omega t. If there would have any kind of phase like pi by 2 or phi or any kind of phase, so we would not have been able to write like this. Then we would have to do and follow the some different way.
हम्म,
Okay. So now we will take the average power. What?
एवरेज पावर.
Hmm. Acha, first of all, right up to here, then we will follow. Further move on. Okay.
हम्म,
Right. Okay. Let me know when you complete.
हो गया.
Okay. Done that. Okay, so as we have told you that we will calculate the average power for one cycle, because now this one cycle is completed here. It means for time period t.
हम्म,
So average power we will calculate, and for I'm writing here for one complete
okay,
cycle,
अच्छा,
for one
कंप्लीट.
uh, so for one complete cycle. So when we want to take the average here, so acha, tell me one thing, V naught and I naught. V naught is here. See
हम्म,
the graph, this is V naught, right? In the similar case for the current equation, that would be I naught. Similarly, it means
हम्म,
V naught and I naught are the maximum or peak value, so it means there is no fluctuation in v naught and I naught. This is fixed.
Hmm.
So in what term there is changes? I think sine square of omega t. Only this term create the difference in the power. Sine square omega t. So we need to take the average of this term, sine square omega t. We will take the average of sine square of omega t. Okay. It means v naught and I naught. This will remain same. And this is what? This is sine square of omega t. But we will take the average of this, and average of this trigonometrical term for the one complete cycle. Okay.
Yes, sir.
So we can also use directly the average value of the sine square omega t, and the average value of sine square omega t we can also write like this: sine square of omega t. It means its average value, and this average value is 1 by 2 only. What value? 1 by 2.
Back
But
to.
but I want to show you that how did we get this value. Okay.
Hmm.
So let's see. We are finding the average of sine square.
I don't
Okay.
have to write this now.
What
Average.
average of sine square omega t we are going to find out.
I don't have to write that, no?
Okay, okay, you don't have to write. I am just telling you for your information only. You don't have to
Hmm.
mention. Okay, for the sake of your information only, I am telling you. So see and got this. So average of sine square omega t. How do we find the average? First of all, we take the sum of all the terms, then divide by the number of terms. As in the case of VRMS and IRMS, we have calculated. So this, since there
Hmm.
is a function, so we will take the integration of this function under the limit 0 to t, sine square of omega t and dt, and we will divide it by the t as well.
Hmm.
This is the way to find out the average. We have done this in previously we have done this. So this is 1 upon t, and this is 0 to t. This is capital T, which is time period, and this is the sine square of omega t. So here we will use the one of the trigonometrical formula, 1 minus 2 of sine square x. Okay. Now this minus
Hmm.
2 sine square x, when you bring this toward the left side, so this will become 2 sine square x, and this is 1 minus cos 2x. Fine.
Hmm.
Now sine square x will be equal to 1 minus of cos 2x upon 2. Any problem? So simply
No.
we will substitute this term here. So note one thing, this is a 1 upon 2. We can write like here, and the remaining term, which is 1 minus cos 2 2x. X is the angle. It means whatever you have the angle, simply you have to double that. So here we have the omega t, so double of that will be 2 omega t. Fine.
Hmm.
Dt. Now this is what? This is 1 upon 2t. Okay. Now we will distribute this integrations. So directly I am doing this. So when you open the bracket, you will get 0 to t integration of dt, and integration of dt is t only, and the limit is from 0 to t. And when you integrate this term cos, integration of cos is sin x.
Hmm.
Integration of cos dx is sin x.
Sun.
Okay, but we will use the chain rule because it contains the 2 omega t, so we will differentiate in the denominator again. So when we
Hmm.
take the integration, so we will find out the sine of 2 omega t, 2 omega t, and when we differentiate this 2 omega t term, so simply we will get 2 omega only in the denominator, and
Hmm.
then we will apply the limit here, 0 to t. Now this is 1 upon t. Pay very careful attention while solving these terms. So when we apply
Hmm.
the limit here, so limit is always applied from upper limit minus lower limit. It means here we will have t minus 0 only, and 1 by 2 omega is independent of the small t, so we can take out as a common, and the
Hmm.
remaining term which we have sine 2 omega t, and we are applying the limit for the function is small t only. So remember this term because the integration is doing with respect to the variable t.
Hmm.
So the limit will also operate on the t naught omega and any else other term. So when we operate the upper limit, it means this is 2 omega, and in place of t we will simply put capital T. Fine.
Hmm.
And then minus lower limit, when you put 0 here, so everything will become 0, and sine 0 of 0 is 0. Fine. Okay. Are you getting or not whatever I am doing?
Yeah.
Tell me.
Yes, sir.
Okay, this is 1 by 2t, and this one is t, and this is 1 minus 2 omega. And now we need to solve this term individual separately. See here, this is what, this is sine of 2 omega and capital T, right? Capital T.
mm,
Okay, this is sine and this is 2. Now what we can write in place of omega? 2 by omega, 2 omega by T, and this is T. Okay, now this T and T will cancel out. Are you getting or not?
yes, sir.
So we will have only 4 pi, and we know that the integral multiple of pi is always 0. Value of integral multiple of pi is 0. It means sine n pi is 0. I have told this earlier that whenever we have the term like sine n pi, so this is always equal to 0 whatever be the value of n which is belong to the integer, right? So it means overall we have this whole term is equal to 0. Fine. Now this is 1 upon 2t, and this is capital T, this is minus 0, and this is 1 upon 2t, and this is t, and t will cancel out. So finally we will get 1 upon 2 only. Okay.
Mm,
So this was the result which we have to calculate it, but we will not mention this process here, and we will simply directly make use of this term that the average value of sine square omega t is 1 by 2. So did you get this or not?
mm,
Any doubt? No. Any
I
kind of
got. Mm,
any doubt or not?
no doubt, sir.
Okay, okay. So I am going to erase this portion. Okay.
Mm,
So we know that the average value of sine square omega t is what? 1 by 2.
mm,
1 by 2. Okay. So we have calculated the average power which was V naught into I naught into sine square omega t, and this average value is 1 by 2, right? So we can write
mm.
this 2 as V naught by root 2 and I naught by root 2. Any problem?
No, sir.
Because 2 can be written as the product of their square roots like this. Acha, now tell me one thing. What is V naught by root 2? Is it VRMS? And what is I naught by root 2? Isn't it IRMS?
Mm,
So this means the average power is equals to VRMS into
I am.
IRMS in case of purely resistive circuit.
Sir, the screen is frozen.
Screen is frozen. How it happened? Let me check it out. Is it fine?
Mm,
No.
no, sir.
Is this not visible to you? Whatever I have written on the screen.
No, sir. I mean it is, but it
It is
is
time lagging.
frozen.
Frozen time lagging.
Mm,
Okay, so disconnect and again connect in the 2 minutes. I am again restarting the system because I think there is some issue in the software.
okay, sir.
Display software, there is some issue. I am going to disconnect and join that again after restarting. I will inform you over the WhatsApp. Okay, stay connected in the WhatsApp group. Okay, hello, hello.